So far, you've learned from chapter 7 what a parabola looks like. I taught you how to read transformations. Then we started 5A, 5B last week where I told you there were 3 key formulas. One was distributive law. So all students, what's going on? All students will know how to expand this if they're planning to do methods. They usually know how to do that. So that's skill number 1. But that's what most students stick on. By the time they get to year 11 methods, they only do that one skill. The other 2 skills I wanted you to know was the perfect squares expansion. Let's see if you remember. What's the rule to quickly expand a plus b squared? Yes, Sanvi. Beautiful. This is what I want you to get familiar using and identifying when to use them. It's also going backwards as well. So going forwards is one way, and then the other one is going backwards. If you can recognize that, that's a skill that they want you to have. The third skill is a very common one that they chuck in at the senior levels. It's called difference of perfect squares. So if you have a minus b multiplied to a plus b, that can be simplified to what? Hands up. Molly. A squared minus b squared. That is correct. Difference of perfect squares. Okay, so this one I often see students kind of know if it's this obvious. For example, something like this. Most students will know if they've practiced a bit. But then it's the other stuff. So for example, I can give you 2x squared minus 5, and that's where I can tell from a year 10 student who's able to do that, what the answer is and all that. And then you can expand that and make it more complicated by putting brackets in as well. But that one will stump a lot of students. Most students can do this, and they can't do that in the exam. Out of curiosity, anyone know the answer?
Does it involve surds?
Yes.
2x plus square root.
Ooh, close.
Plus
5. Root of 2x minus 5.
Beautiful. If you got somewhere around there just by observing it, well done. Most students won't get that, okay, because it's got surds in it and it's the understanding of what difference of perfect squares is. Well done. So that gives you the algebra. So if you happen to get these brackets, those are the techniques you've got. Today's lesson, you're not dealing with expanding. You're not dealing with 2 terms only, so a squared minus b squared. You're dealing with what we call trinomials. Tri meaning 3. So in your expression, in the quadratic expression, you end up with 1, 2, 3 terms. The reason why it gets tricky is because not all terms have something in common. So for example, over here, these first two have an x. Yes, you can factorize those, but the last one doesn't. So then it makes it a bit trickier. Same thing with, and all of these, they don't have any common factors in terms of 2s and 3s there. Same thing with this one. This is an x squared and an x. Yes, they have a common factor, but all 3 do not have something in common. So there has to be a technique to solve. D and E explore, or D gets you to practice what we call monic trinomials, and then non-monic is what I want you to learn, okay? Because monic, every student will eventually learn just through YouTube and all that, and they'll memorize this one fact, and they'll always use it, but it's the non-monic that really trains the skill, okay? So if anything, you want to be focusing more on 5E, yeah? So this is 5E over here, and this is 5D. What's the difference between the two? How do you know one's monic and one's non-monic? It's based on the coefficient of x squared. Coefficient means the number in front of x squared or number multiplied to x squared. Notice all the numbers on this side, the coefficient of x squared is 1. That's called monic, so it's 1, which makes the calculations much easier because factors of 1 is just 1 and 1. Whereas over here, this is called non-monic, which is harder because you have to consider the variations and the different possibilities, what your factors could be. And because of that, that first number actually dictates a lot. Because the first number dictates in your brackets, so if you remember in these brackets here, your a times c will vary a lot. So that x squared, it could be 1x times 2x, or for example 15, it could have been 3 and 5, 1 and 15. If you had 24, that could have been 1 and 12, 8 and 3, 6 and 4, 2 and 12, and 1 and 24. So there's many possibilities. That's why these are harder. Okay, so non-monic, when they say non-monic, what they mean is the number in front of x squared is not 1. Whereas when they say monic, A is equal to 1. Okay, so monic is much easier to do, and then non-monic is slightly harder, but if you know the technique, you do both the same way. Okay? All right, so let's do an example. Let's do an example just so you can see. So there are two techniques that you can learn. One is in the textbook, and the other one is a bit more intuitive. So grouping method is the textbook one. So if you wanted to follow the textbook and you want to learn by yourself, this is neater as well. To me, it takes a bit longer. So that's your textbook version. The cross method is how I learned it when I was in high school. So it's a bit more intuitive. You do a bit more trial and error in your head, and you choose the most likely answer. So it's faster, but to start off with, it feels very uncomfortable if you've never done it before. So this one is a bit more intuitive, but in my opinion, it is faster. In both methods, you need to look at the factors of A and C. So you look at the coefficient of x squared, and you look at the factors of the constant term. Okay? Both techniques will look at the factors, and you're trying to get it to work out to get your B. I'll show you a picture later, and you might want to use the third method that I found in year 10. Some weaker students were able to use this visual aid to factorize. Okay, so here we go. Let's do the first two first, and then I'll show you the third one. First two. So let's say I give you a mnemonic trinomial. So the first one is x squared plus 3x plus 2. Our goal when they say factorize is you want to get it into two brackets. Okay, so it's not a difference of perfect squares problem, and it's not a perfect squares expansion. So now we're left with whatever this is. So let's try the first one. So cross method, you have to look at the factors of A, and you look at the factors of C. C is currently 2. So what are my factors? What are my two pairs? Give me two numbers and multiply to give you 2. 2 and 1. So you only got 1 and 2. Now I like to write them in pairs. So I write them in a row like that. Whereas the other one is A equals 1. So then pairs for 1 is 1 and 1. This is what makes monic much easier. Because you only have 1 and 1, you don't have any other options. You choose the left pair and the right pair. Your goal is to match them somehow to get plus 3. Okay? So I'll show you what I mean. This 1 and 1, to get an x squared, that means this is 1x. So I'm going to write it again. This represents 1x, 1x. Means that the possible combination you have is 1x and 1x. That's the only way to get that x squared. So you can have 1x times 1x when you do the distributive law. That's what the 1 and 1 represents. What you need to now figure out is the 2, because the 1 is going to be paired with something over here. And this one is going to be paired with something over here. So the way we call it, why we call it cross method, is because this is what you do. You write out 1x, 1x. So that's the pairing for the first one. And then you look on the right-hand side. Usually you have more pairs to choose from, but in this case you only got 1. So now you have to decide, is it 1 then 2, or is it then 2 and then 1? Reason why it's called cross method is because you have to pair the green and the blue. So you either pair the 1x with the 2, and then this one with the 1x. But can you see with monic, it actually doesn't matter because both of them are 1s. But in non-monic, it does matter where the order would be. Which one do you pair with? That's why they call it cross method. Yeah? So in a monic, you just need to pair them first. So let's say I paired the 1x with the 2. Now you ask yourself, you say, if I paired 1x with a 2 means I'm going to multiply 1x to the 2. 1x times 2 gives you?
2x.
2x. Whereas the other one, 1x times 1 gives you 1x. This is where you then zoom out a bit and you say, okay, so with 2x and 1x, is it possible to get 3x? Yes, how though? Because I need a positive 3x. So they need to be both positive. Positive 2x plus 1x will give you that. And that sign matters. So right here, we say this needs to be a positive 2x, needs to be a positive 1x. And so this is where you write them. You say, well, 1x, I paired it with a positive 2. That's the only way to get the positive 2x. So the 1x is now paired with positive 2. The other 1x, we paired it with a positive 1. So that means this one is paired with this one, and it's positive 1. What you see now is if we test it and we expand it. Here we go. 1x times 1x gives you x squared. Yes, that's correct. We've got the first term. What we were trying to do just now is to get the middle term. So we test it by saying, all right, well, 1x we paired with a positive 2. The other 1x we paired with a positive 1. Together, yes, it's true. We do get a positive 3x. So now we've got the middle term. Then the last bit you have to check, because there are some factors where you get the middle term, but you don't get the last term. You have to check, does the last one work as well? So then you say, what about 1 times 2? Or in this case, does 1 times 2 give you, and it should, because you chose the factors of 2. Yeah, so you chose 1 and 2, so it should work. So 1 times the 2, positive 1 and positive 2 gives you positive 2, and that is true. So together, that is your factorized answer. This is called the cross method, so you can see how messy it is. But that's what I mean. We normally do this when I learned it. I do it in the head. So I look at it and I write my answer. That's the approach. So that's why it's faster, but it's not as neat. So as you're doing it, you may feel it's a bit, oh, what do I have to do again? And you find it a bit more complicated to do. The grouping method is cleaner, but I would say that there was some caveats to it, which I'll show to you. Okay.
You can just get rid of the ones at the end, right?
The ones.
Like 1x plus 1.
1x plus 1.
The 1.
The 1x here and the 1x there.
We can get rid of the 1, right?
Oh, yeah. I'm just writing the 1 so that you can see where those 2 1s go. Because later on when you do non-monic, the numbers in front of it will confuse you. So that's why it's good to know where it is. All right, let's do a grouping method. Some of your tutors might teach you this other way, and this is why it only works for monic. Some of your tutors might say this instead. I'm just going to do a bit of a tutor language here. Some tutors will say for monics, they might say, because it's monic, they say, just look at the factors of 2, ignore the first one. So just look at the last one and say, what's factors of 2? You got 1 and 2. And then you just say, do they add or subtract to get you the middle term? And that's all they do. So they teach you to go x, because monic is always going to be x and x. And then find the factors of the last number. So if they multiply to give you 2 and they add or subtract to give you the middle number, you fill in the numbers. So in this case, a lot of students get used to saying, well, 1 and 2 to get 3, they just do plus 1 plus 2. It works only for monic. If you try that for non-monic, it's not going to work. Yeah. So some tutors might teach you that at year 9, but once you get to year 10, that doesn't always work. Okay. Let's do grouping methods. So this is what your textbook teaches you. So textbook teaches you, again, same thing, A equals 1, C equals 2. So your textbook kind of merges between the tutor method and what I just taught you with the cross method. They'll say A times C, very similar to what we were saying before. So A times C, in this case it's 1 times 2, and we get 2. Then they say, can I get the factors of that, whatever multiplication, after the product, the factors of 2, so that you add or subtract to get 3. Factors of 2 happens to be only 1 and 2. Saying yes, plus 1 plus 2. So this is what you do. The grouping method works like this, and it's a bit cleaner. You write out x squared instead of writing positive 3x. Because you've got a positive 1 and a positive 2 to make that 3x, they say plus 1x plus 2x. Can you see how I split that up? The 1 and the 2 get split up, and you still have that plus 2 at the end. So this one gets split up into 2 terms. In the previous lesson, we learnt about factorizing by grouping. So then you group them now. You split them up into 2s. And you say, what do they both, each pair, have in common? So here we go. In the first pair, what do these 2 terms have in common? X. So you take out x as a common factor. You end up with x plus 1. Then you look at the second pair. 2x and 2, what's a common factor? 2. So you take out the positive 2, and again you'll find that you get x plus 1. Now, in our last session, do you remember? These terms, what do they have in common? There's 2 terms here. X plus 1. So here you can see this term and this term, they both share an x plus 1 bracket. So, you take out x plus 1, I'm highlighting it again, as your common factor of these two, and then what's left over? You have an x plus 2. So that x, and that plus 2, or essentially you're saying x plus 1 times what? Gives you the first term. X plus 1 times what? Gives you the second term. So can you see how grouping method's a bit more structured? It's a bit neater. So that's how your textbook would teach you. What's the caveat? Right here. See that bit? That works if the numbers are small. But if I gave you 15 and 17, so A was 15 and then C was 17, your problem is that you're going to have to figure out what 15 times 17 is. Then you find out the factors of whatever that big number is to then add or subtract to get you 3x. So when it gets large, I find that the students who follow a grouping method struggle with the larger numbers. Yeah? Whereas this way you generally pick out the right factors. You don't have to go too big to figure it out. So this is neat, it's clean, it's methodical. The caveat is A times C can be very big. Okay? So let's do the next example. So copy that down just so you can see the differences between the two. I'm going to do it again for the second example. And you can see how I'm moving through using cross method or grouping method. After that, I can show you a third method if you're still struggling with these two. There is a third pictorial method that allows you to sort of get a bit better, especially cross method. So let's say you didn't want to do this one, but this one is a bit too hard. There is a visual way to do this one, and that's what I found my Year 10s were able to pick up once I showed them the visual method. Yeah? Let's try these two first. All right, let's see, what's the next? Oh, it's on the next page, is it? Okay. Flip over. Once you're ready, flip over. Let's have a look at the next example. I'm going to leave B1 for you to do. I'm doing the non-monic one, so you can see how cross method works as well, okay? Let's do it again. So here's non-monic. Same thing again. A is equal to 2. C is equal to 4. So in cross method, we actually look at the factors of them. So factors of 2, in this case, is still nice. It's only 1 and 2. Factors of 4, we've got 1 and times 4. But we also have 2 times 2. So there's 2 options there that you'll likely choose from. How this works now, cross method says, well, to get 2x squared, I would need a 1x times a 2x. So that means you start off with 1x, 2x. You need to pair the left side with the right side. Now you've got 2 options here. You either pair 1 and 2 with 1 and 4, or 1 and 2 with 2 and 2. Which one will likely get you 9? That's where the fast approach comes. Okay, so that's where your logical sort of deduction. Which one's more likely to get you 9? Do I do 1 and 2 with 1 and 4, or do I do 1 and 2 with 2 and 2? Now, obviously, if you don't have that logical deduction, then you will test through them all. For me, I can see that 2 and 4 gets me pretty close to 9 already, whereas 2 and 2 gets me 4. I'm a bit off, so I probably likely would have gone with 1 and 4 just from deduction. But if you didn't see that, then you would have to test them. That's why cross method can be a bit intuitive. Yeah. So here, I would have likely chosen this pairing. That means I would have chosen a 1 and a 4. But the question is, where do I put the 1 and the 4? This is when it matters. See, monic, it didn't matter because both of them were 1s. Now it does. If I do a cross method, 2 will be paired with a 1, and then 1 will be paired with 4. That's why the order does matter. So when you do the cross method, where do you put the 1 and the 4? In this case, I can tell I want a 2 and the 4, so I'm actually going to cross it this way. Okay, so I will choose this pairing, that cross method. This will now give me, when I multiply it, 2x times the 4 gave me what I was predicting, closer to the 9x, so I get the 8x. 1x paired with this 1 gives me 1x. Then I ask myself, can I add or subtract these two numbers, 8 and 1, to get the 9? Add. Both of them have to be positive. So here I would say, this needs to be a positive 8. That needs to be a positive 1. So that means this 4 has to be a positive. That'll be 2x times positive 4 to get the positive 8x. And then 1x times, this has to be a positive 1 to get that 1x. So now that I've got my pairing, let's write out our brackets. Here's my two brackets. So the factors I got was 1x, 2x in green. So I said 1x and 2x will give you the first term. So 1x, 2x. What matters is here. This is where the cross method matters. What number did I pair the 1x with? With 1. All right, so it was 1x with the 1. So right now 1x times 2x gives me 2x squared. Good. But I need to pair this 1x with a 1. So the number over here has to be plus 1. If you put a plus 4, then everything gets mixed up. Because here you said it's 1x paired with a positive 1. So it has to be in this bracket, not in the same bracket. Okay, so over here, this needed to be a plus 1 because we're pairing them. So it's distributive law, 1x times 2x, and then 1x times positive 1. Whereas the 2x, it was being paired with a positive 4. So that means 2x, when you multiply it, the positive 4 has to be over here. If you swap the two numbers, then it's a different answer. Okay, so that's why the cross method, as you're doing them, you fill this in. Later on, you don't actually have to do this bit. This is what I do in my head. I actually just write out the answer. That's the intuitive bit. Yeah. So now let's test it. Let's see if it's actually correct. So if I expand it all, 1x times 2x does give me 2x squared. That's good. I get 2x squared, so we tick that one off. 1x paired with a 1 gives you plus 1x. 4 times a 2x gives you plus 8x. And together, that does give you 9x, so that ticks that one off. And the last one you got to check, does plus 1 times plus 4 give you the last term, which it does, plus 4. So the cross method is the answer would then be x plus 4 times 2x plus 1. Doesn't matter the order of the bracket, but what's inside the bracket matters. Okay, so you can swap it around and say 2x plus 1 times x plus 4, but that's cross method. Now let's cycle to grouping method. So this is your textbook method. It's cleaner, it's more methodical. The problem is when you get large numbers, for example, the third one, so that 15 and 8, you would end up multiplying 15 and 8 and you get a bigger number. Okay, so the larger the number, the worse it is. Smaller numbers, you can use grouping method and it'll be just as effective. Here we go. Let's do grouping method again. Same thing. A is 2. C is 4. Grouping method says times them 2 together. So A times C, which is 2 times 4, gives you 8. Now you look at the factors of 8. Factors of 8, we've got 1 and 8. So 1 times 8. You've got 2 times 4. I think that's about it. Yeah. Now, out of those two pairs, which one can add or subtract to get you 9? 1 and 8. Very good. So this is the pair I'm going to choose. So in the grouping method says, okay, so that 9x, we're going to split it up in 1 and 8. We're going to split it up into 2. So here we say 2x squared. I'm going to split out 9x into 2 bits, and it's plus 1x plus 8x. Plus 4. And it doesn't matter which order, it'll always work out. Okay, you could have swapped it around and said 2x squared plus 8x and plus 1x plus 4. It would have worked as well. Okay. Here we then group factors. So we split them up into 2s and we say what is the common factor of either one. So let's look at the first pair. 2x squared plus the 1x. What is common about those two terms? 2x squared and 1x. What's common? X. So then you take out x as a common factor. That means you get 2x plus 1. Then you do the same for the next one. What's common about 8x and 4? 4. So you take out 4. And you end up with, again, 2x plus 1. Then you look at those two terms again. This is why it's called grouping method. What do they both have in common? 2x plus 1. Very good. So you can see here they both have a 2x plus 1. So when you take out the common factor, you say, well, they both have a 2x plus 1. 2x plus 1 times what? To get you x times 2x plus 1. That's your x, and that's your 4. So you can see that's the leftover factors. So it's neater. You see how the difference between the two? One's neater, one's cleaner. That's how your textbook teaches you. The only con that I see students struggle at Year 10 is when I start making the numbers much larger, A and C. So I might give you like, I don't know, 21 and 49. Then when you multiply those two, you get a really big number. And unless your factors and your multiplication is really good, that would be okay. Otherwise, you get stuck here. If you get stuck there, you can't get these two. When you can't get those two, the rest falls. Yeah, whereas if you do it this way, breaking up in the factors first, it's actually smaller. 21 has only, 7 and 3, and 1 and 21. It's actually in 2 pairs there. And if you think about 49, there's only 7 and 7, 49 and 1. So it's actually much easier to figure out intuitively. It just looks messy. Yeah? I'm going to pour, should I show you? Can I get a show of hands just so I know how you're feeling at the moment? Can I show of hands who feel as if that cross method is a bit confusing for them? Can you get a show of hands? Okay. Hands up or hands up if you felt grouping method's easier to understand than cross method. Okay, I want to show you the third method so that you can try to do the cross method a bit easier, pictorially. Okay, let's do this pictorially. I'm going to keep the exact same example. Let's do this one. Here's the pictorial way. Method 3. They call it Punnett squares. So if you want to search it up, it's called Punnett squares. This is how it works. You draw a square, cut into 4 quadrants, and this is literally what you do. Whatever we're doing in this Punnett square is exactly what we do in cross method. It just looks easier to think. This is what you do. You say, first one, A is 2. Factors of A, which we said 1 and 2, is what you do. You write all the possible factors to get you the first term. So it's 1x times 2x, so it's 1x and 2x. So that goes in the first 2 sides. Yeah? So that's how you get 2x squared here. So all good. The only trial and error bit comes in this next 2 box. Next 2 box was based on C. Factors of C, you've got these options. You got 1, 4, or the other way around. 2. Sorry, I should write it like this. I'll write 1, 4, 2, 1, 4, 2. Okay? So, in a way, you can think of it as 1 times the 4. So 1 and 4 will give you the 4 that you need to get a 4 here. So you want a 4. Maybe I'll do it in order. Sorry, let me fix that again. So if you chose factors of 4 as 1 and 4, so you got 1, 4, or you could have had 2 and 2. But you could have also had 4 here, and then that means 1 is there. Okay, so they both have 1, 2, 4, 4, 2, 1, but they're just paired. So 1 and 4, 2 and 2, 4 and 1. To get 4 in the last column. Yeah? This is the only trial and error bit. Your job is to figure out, I need them to add up to 9x. So is it 1 with a 2x to give you 2x here, and then that's 4x there? So 1 and 4, that would give you 4x here and 2x there. So the options you can get are 2x, 4x, or you can get 2x, 2x. Sorry, that's 2 and 2, so that's 4x there. And that should have been 1 and 2x, yeah. That's 4 and 1, good, yep. Or the last one is 4 and 2 gives you 8x. And then that means it's 1 and 1, that's 1x. So out of them all, which ones will add? Is it 2x and 4x? Is it 2x and 4x again? Or is it 1x and 8x? Usually I don't write all 3. I actually just sit there and I just think about it. So my year 10 student actually just looks at the number and then figures out which one it is. Sometimes it's easier if you just write one of the pairing and then rub it out, write in the second one. So clearly the one that gets you the 9 has to be 8x and 1x there. So the only numbers that would have worked out was 4 and positive 1. Okay, so that's what the Punnett square is. It's exactly the same thing as the cross method, but visually it's a bit easier. So what would your answer be? It would have been 1x and a positive 4 for one bracket, and the other one would be 2x and a positive 1, which is exactly what we got up here. So 1x with 4, 2x with 1. Punnett squares could well help.
I don't really get it. What do you multiply?
The length by the width. So each area, so this area would be 2x times 1x to give you 2x squared. This one, depending on which one you chose, is a length of 1 times by 2x. If you did 1 times 2x, then you get 2x. But then if you chose 1, then that one had to be a 4. So then if this is 4, 4 times 1x gives you 4x. So 2x and 4x doesn't add up to 9x. Does that make sense? Or if I draw it a bit more, instead of doing all three in one go, you could have done it like this. And you could have done 1x, 2x, and chose a factor. So if you did 1, 4, you can actually fill it all out now. So you can say 2x squared, that's 2x, that's 4x, that's 4. And you ask yourself, does that add up to 9? And if it doesn't, rub it out again. You try the next two factors because you want to get a 4. So then it could be a 2. And you say, all right, well then 2 times 2x gives you 4x. 2 times 1x gives you 2x. Does that now give you the 9x? And it doesn't again. So you go, okay, well it can't be that. Then maybe this time it's 4 here and a 1 there. At the end of the day, you need a 4 here. So 4 times 1 gives you that. So here, 4 times 2x gives you 8x. That's 1x. Now that works. So if that works, remember to get that positive 8, that had to be a plus 4. To get that positive 1, that had to be a plus 1. So your two factors are 2x plus 1 times 1x plus 4. Okay, so on a visual aspect, this is easier than what I was just showing with cross method. It's a bit more, you can rub it out and all that. Later on, you don't have to do the rub out. You just do the one Punnett square. You can do that. Okay. I'm going to pause the video. I'm going to give you a shot. I want you to try out a non-monic, 15x squared plus 14x minus 8. Use the 3 methods. I don't care which method you use, you just have to get it right. Okay? I'll pause the video there for today, and then next lesson you practice it again. I'm going to give you a worksheet, and we're going to keep practicing until you become masters of factorizing trinomials.
Masters.
Yes, that's right.